Interpreting and creating graphs. George and his family were watching a movie and eating popcorn. Each family member had a bowl with the same amount of popcorn. The graphs below all show the amount of popcorn remaining in the person's bowl over a period of time. Under each graph, write a few sentences describing what may have happened. So the first thing I want to look at is I want to look at the title of the graph. We're talking about George here. We're going to look at the different axes. So we look at the y-axis and we look at the x-axis. Okay, the y-axis is showing us that it's the amount of popcorn that he has, and the x-axis shows us time. So if I trace this line, I can see that the amount of popcorn is going to be decreasing as time passes by. Okay. Whenever we see a straight line like this, it means that it's changing at a constant rate, or he's eating it at the same pace. Another thing that we need to be aware of is that the amount of popcorn left in the bowl depends on the amount of time that he's been eating the popcorn. So your y-axis is always going to depend on what your x-axis is. So this would be your independent variable, and this would be dependent because the y depends on the x. So my sentences would look something like this. George had a bowl of popcorn, and he ate it at a constant rate until all of the popcorn was gone. Okay, now we're going to look at the next graph, and we see that it's talking about George's sister. That's the title. And we're going to label our axes. This is our y-axis, amount of popcorn, and our x-axis is time. Okay, we can see in this graph that we don't have a straight line like we did over in George's. So George's was a straight line, that was a constant rate of change, or he was eating at the same pace. George's sister here, it's not, none of it's straight. It's a little bit curved all around, so she's eating at a different pace. She's eating kind of slow here, and then it speeds up, and slows down, and then speeds back up, slows down, speeds back up. Okay, other than seeing that, another thing that I notice is on George's popcorn, he ran out. So he got all the way back down to the x-axis. So the amount of popcorn, right, he had some in the bowl, it went down to nothing. For his sister, she started with some popcorn, but it didn't quite go down to the x-axis, so she still had some left in her bowl. So my sentences would look something like, George's sister had a bowl of popcorn. She ate slow at first, and then she sped up a little. Throughout the movie, she ate at different rates, and then by the end of the movie, she had very little popcorn left in her bowl. Okay, now we're going to look at another graph, still dealing with the popcorn. So now we're talking about the amount of popcorn that George's dad had. So we will label our axes. We have the y-axis here, and our x-axis is there. So the y-axis is the amount of popcorn, x-axis is time. So remember, the amount of popcorn is going to depend on the amount of time that we've been eating. So this is your dependent variable, and this is your independent variable. Okay, when I look at this graph, of course he's starting with some popcorn in his bowl as well, and he's going to eat at a constant rate. The reason I know this is a constant rate is because it's a straight line. Okay, so he's eating, and he stops eating, and maybe about half the movie he doesn't eat any popcorn, and then he just decides to eat some more, and he eats that at a constant rate until he's run out of popcorn. So my sentences would look something like this. George's dad had a bowl of popcorn. He ate it at a constant rate. He stopped eating for a little while and began eating again at a constant rate until all of the popcorn was gone. Okay, we're going to look at the next graph now. It's George's mom and the amount of popcorn she has over time. So we will label our axes. So this is our y-axis, and this is our x-axis. Y is going to depend on x, so the amount of popcorn in the bowl depends on how much time has passed by. So dependent variable, independent variable. Okay, so if I'm looking at this graph now, I notice that she started obviously with some popcorn here as well, and she did not eat any to start the movie. Then after it got going, she decided to eat some, and she ate it at a constant rate, okay, or at the same pace for a certain amount of time. Then she stopped eating again right here, and she did not eat any more for the rest of the movie. So my sentences would look something like this. George's mom had a bowl of popcorn. She did not eat any at the beginning of the movie. She then began eating at a constant rate. After some time, she stopped eating and did not eat for the remainder of the movie. For the next 4 graphs, we want to create our own scenarios. So first thing we want to do is label our axes. So there's our y and x. For x, we're going to call it time, and we're going to have money over here. So in my scenario, we're going to talk about the amount of money in the bank over a certain amount of time. I notice right here that he's starting with no money in the bank, right? Or it's at a point here, and I'm saying that he has no money in the bank. And over time, his bank account is increasing, the amount of money is increasing at a constant rate. So that could be he's making a deposit every month. So maybe after 1 month, it's $10. After another month, it's another 10. Another month, another 10, and on. So he's depositing the same amount each time. Okay, in graph B, we need to label our axes, y-axis, x-axis. We're going to use the same scenario with money and time. Okay, but in this one, I noticed that we're not starting at 0. So it's like he had an initial deposit. So he had some money in the bank, and then from there, over time, he increased his bank account by the same amount each time. So there was a constant change in the amount of money in his bank, and it was going up from there. Okay, for graph C, same thing. Y-axis here, x-axis here, x is time, and y will be money, or the amount of money in the bank. He's starting out with nothing here, and then he's depositing some money in a short amount of time, so this is going up here, and then he stops depositing, and it stays at the same amount of money in the bank for the rest of the time. In example D, or graph D, we want to label our axes x and y. The y is going to be money in the bank. X is going to be time. Alright, I noticed in this graph that we have 2 different lines. They're connected. So this one's showing me a constant rate of change up to this point, and then the rate changes for this line. Even though they're both a constant rate of change, one is changing at a faster rate than the other. So this one is a steeper line, so the amount of money is increasing at a faster rate than this line. Okay, journey to the bus stop. Every morning, Tom walks along a straight road from his home to a bus stop, a distance of 160 meters. The graph shows his journey on one particular day. Okay, so first thing I want to do is I want to look at what my axes are. So the y-axis is the distance from home in meters, and the x-axis is time in seconds. So then I'm going to look at the lines, and I see that we have a constant change here. It's increasing to about 100 meters, and then turns around, it goes back down to 40 meters, and then it goes up to 160 and stays there. So here's a story that could have happened. So Tom is walking towards the bus at a constant rate. Maybe he's on the phone with his friend, and his friend says, "Hey, come back to my house, and I want to walk with you." So he walks to his friend's house, which is back towards his own house, picks up his friend, and since he's now running a little bit late, he increases his speed as he walks to the bus stop. Once he gets at the bus stop, the bus isn't there, so he has to wait a little bit until the bus gets there. Okay, for each of these stories, we're going to create a graph that represents the situation. So for the first one, number 1, it says, while Mikey was standing on the beach, he threw a rock as high as he could before the rock landed in the water. If I'm going to represent this, we know that Mikey's not throwing the ball from the ground, so we're not going to start at 0 here. We're going to start up a little bit. So maybe he's throwing the rock from this point here, and he's going to throw it up in the air as high as he can. So over time, the rock's going up, and then it flattens out, and it comes back down and lands in the water. So the height of the rock is starting in the air in his hand. It's going to go into the air, and then it's going to turn around and come back down, and then it's going to go past where he threw it, right, because he was already in the air, and then it's going to land in the water. So if I continued this graph, it would probably sink under the water and then down to the floor of the lake or whatever it is. Okay, example 2, or number 2, David sprinted for 20 seconds. He stopped for 30 seconds to catch his breath. He then continued sprinting for 20 more seconds. All right, so I'm going to take David, and we're going to start here, and he's going to sprint for 20 seconds. Then it says he stops for 30, and then he sprints for 20 more. Okay. So over time, we see that, so here's the seconds. So over time, he's sprinting, he's going somewhere, so his movement is here. Then he stops and he stays at that same spot for 30 seconds. Right? And then from there, he's moving again, so he's for another 20 seconds. During a recent thunderstorm, the water level in the river increased at a steady rate and remained at a higher level for a period of time. The water then decreased nearly to the original level. So the river's not going to be empty, so we have to start somewhere. So we're going to start maybe around here somewhere. Okay. And then we see that the river increased at a steady rate and remained there for a period of time. And then it decreased nearly to the original level. So this was my original level, and it nearly met that, but not quite. Okay, number 4. The pilot decreased the plane's altitude to adjust for turbulence. Once the turbulence was over, the pilot returned the aircraft to its previous cruising altitude. Okay, here we have time, and this will be altitude. So the pilot they're obviously in the air to be able to adjust their altitude for turbulence, so that means they're up in the sky. So we're going to start them up here somewhere. And then it says they are going to decrease the altitude. And then it's going to sit there for a little bit until the turbulence would be gone. And then they will return to their cruising altitude. Okay, number 5, Diane threw her paper airplane. The airplane lowered at a constant speed, leveled off, and then rose at a constant speed until it was caught by Diane's friend Ellen. So for our x-axis, we will have time, and our y-axis will be the height of the plane. So she threw it from some point, not the ground, so we're going to start here, and it says her airplane lowered at a constant speed, so it's lowering. Leveled off means it's not going up or down, and then it rose at a constant speed until it was caught. Attendance at the library's summer reading program was good at first, but it decreased steadily and then leveled off as families began their summer vacations. Okay, so for our x-axis, we're going to have time again, and the y-axis will be the attendance at the library's summer reading program. So it says that the attendance was good at first, so we're going to start up high, and then over time it decreased steadily. So we will show that by a decrease, and that's a steady decrease or a constant change. Then it leveled off as their families began their summer vacations. Okay, so here I see it's telling us that it decreased steadily, so that's a constant rate of change or at the same pace. And then if it levels off, that means that it's not going up or down. So then it's just flat like that.